Alright, geometry. Here we go. It is Unit 9, Part 5 of 6. The name of the game now is segments. That's what we're going to be looking at. Segments and their measures, of course, because that's what geometry is about, measuring. So we got three possibilities. Either as chord, which means all the lines are on the inside. Do you see that? Everything's on the inside. Or we got secant, where we got inside and out, or secant tangent, where it's inside and out and then just out. So we have all these things down here, but I like to think that it's n times n equals n times n is usually kind of how I remember that one. And then for this one where it's got an inside and an outside, it's really n times the whole, or not in, it's out times the whole. Remember, the whole is going to be the in plus the out. Both pieces put together equals the out times the whole of the other one. And then for this third one, it's really just kind of a specific version of the secant, where this outside and the whole are the same thing. So it's really the outside times the whole equals the outside times the whole, just like before, except the outside and the whole is the same thing, so it's kind of like the outside squared. This out times whole is the same as out times out, which is out squared. Okay, I know that doesn't really make a whole lot of sense right now, but it will, because we're going to practice it again and again and again until we start to get it. So here's the general idea. We are inside the circle. Notice that? We have chords, which means I'm going to take these two multiply and these two multiply, and then those are equal. So that means that 6x equals 3 times 5. Okay, so that being said, I got 6x equals 15. It's just simple algebra. 15 divided by 6. What's that going to be? X equals 2.5. Right, let's look at another one. 2. This one has an outside here, z, but it also has another one. It's like z and z. So this means that 4, the outside, times the whole thing. Well, what's the whole thing? The whole thing is going to be 4 plus 12, which is 16. So we got 4 times 16 is equal to the other one, which is z times z. Well, that's going to give me z squared. And 4 times 16, that's like 4 times 4 times 4, which is 64. Oh, well, that's nice, because that square roots evenly. So z equals 8. All right, let's look at this one. We see the 4 and the 6, and then we got the 3 and the x to be multiplied. So 3 times x equals 4 times 6, because we're inside, so we're just going to do the end pieces. And that's 24, so we're going to divide both those sides by 3, and we have x equals 8. Cool. Alright, so here's a tip. Maybe this will help sometimes too. When you see an inside and an outside piece, we know that we're not really going to use that inside piece, but we are going to use the whole thing, which does, I guess, use the inside, but it's a different number. It's 15. How did I come up with that 15? Well, 7 plus 8 is 15. And for this other one, it's 5 plus x. And this 5 is going to go with the 5 plus x, and this 7 is going to go with the 15. So that means I have 7 times 15 equals 5 times 5 plus x. Right, now I see something, I don't know if you see it, but I see it, and it would actually make my numbers a little bit smaller, maybe a little bit easier to deal with. I see that both these have factors that are divisible by 5. So I'm going to divide the 15 by 5 and this 5 by 5. It gets rid of that 5, and I just have 5 plus x equals, well, 15 over 5 is 3, so that's 7 times 3, which is 21. Much easier to deal with now, so we subtract 5, and we get 16 equals x. That is so cool. So cool. Alright, Let's do some more of this. Okay, so now we have the 8 times the 8 plus x is going to be the whole thing. Over here we have 6 times 6 plus 14, which is 20. So we'll have 6 times 20. It's the outside piece times the whole. And then for the other one, it's going to be the outside piece, which is 8 times 8 plus x. You know, this one, I'm not going to do the same fancy algebra. I'm going to do this one a little bit, kind of the long version, I guess, the more traditional route. If I distribute this 8 on the left side, I'll have 64 plus 8x equals, and then on the left or on the right side, 6 times 20 is 120. From here, we have a little bit more algebra to do. Subtract 64 from each side. We'll have 8x equals 56. When you divide by 8, it's nice it goes in very evenly here. This would be x equals 7. So that's our answer for that one. Okay, now what do we have going on? Okay, so we got some big numbers. Some big numbers. So we have the 16, which is the out, but it's also the same as the whole. So it's going to be 16 times 16 for one of them. And this other one's going to be 8 times 8 plus y. So let's set that up. 16 times 16 equals 8 times 8 plus y. Alright, so 16 times 16. What would that give me? I think it's 256. And over here I got 8 times 8 plus y. Well, that's going to be 64 plus 8y. Let's see if I can subtract 64 from each of these. And that would give me 198 equals 8y. Is 8 going evenly? As long as I've been doing the other calculations right, it probably will. Let's see, 198. So this is going to give me, 8 goes into this how many times? So it looks like twice. And that would give me 16. I'll be left with 38. I think maybe I made a mistake here in subtracting. I did. And here is the error. 256 minus 64. Well, that last number there is going to be a 2. And 25 minus 6, that is 19, so it's 192. This is 32, which means it goes in 24 times. So y equals 24. There we go. Lots and lots of algebra, lots of calculations, but we're still getting to the actual values. So it's a big deal to kind of notice, am I inside, outside, on the circle, what am I dealing with here as far as where the segments are. Okay, now we're going to have something just pretty much with bigger numbers. So here's what we have. We got this outside piece 17, but then the whole thing, and we have to add to that. It's going to be 17 plus 2x. And on the other side, we got 15, but then we're going to add this inside, and that's going to be x plus 9 plus 15. Let's simplify that a little bit. That'll be x plus 24. So the x plus 24 is going to match the 15 here. So that's what we're going to multiply for those. And then I'll do these in triangles. 17 times 17 plus 2x. It says find it to the nearest tenth, which to me says it's probably not going to go in, with integers. There's probably going to be some remainders there. So let's at least set it up. 17 times 17 plus 2x. Going to be equal to 15 times x plus 24. Right, so we can at least simplify a little bit here. 17 times 17, or 17 squared, is 289. So this is 289 plus 2 times 17 is 34x. On the other side, we'll have 15x. Then I got to distribute to the 24 as well, so let's see what 15 times 24 is. That'll be 360. And now we can just do a bunch of algebra. Minus 15x, minus 15x, minus 289, minus 289. We're left with 19x equals, and then on the other side, let's see, we'd have 11 plus 60, another 71. So we're going to divide by 19, and let's see what we get for x. 71 divided by 19, that gives us 3.7, about. Cool. Alright, for this next one, I kind of ran out of space here, but that's okay. It's actually a little bit easier as far as the setup. We just have the 6 matches this 20 minus x. Then on the other pieces we have 2x times 3x. Ooh, we're going to have an x squared in there. Let's see what happens. So I'll have 2x times 3x equals 6 times 20 minus x. Okay, now I see a couple things. First, I see that this is going to become 6x squared. On the other side, I also have 6 times 20 minus x. And what I'm going to do is divide both sides by 6 to get rid of those 6's. Then I'll have x squared equals 20 minus x. Okay, so what do I see? I'm going to move this x over to here, and I'm going to show you guys one of my cool tricks too with seeing this. That's going to give me x squared plus x equals 20. Another way of thinking of that is if I factor out an x from each of these, that's x times x plus 1 equals 20. That's like saying some number times a number 1 more than that is going to equal 20. Well, let's see what types of numbers multiply to 20. We've got 2 times 10, 4 times 5. Hey, look at that. 4 could be x and 5 could be x plus 1. And if I multiply those, that means x equals 4. So that must have been the answer. And it equals 20. Excellent. Excellent, excellent, excellent. Oh, wait, but they didn't even, that's not what they're telling me to do. I know x equals 4, which means 2x equals 8, 3x equals 12, and 20 minus x equals 16. They're asking me to find UW, which is this whole length here. So that's 8 and 12 put together, which is 20. Okay, there we go. UW equals 20. Next. Which one of these is closest to the length of ST? Oh, man, that's hard. Alright, well, you know, there's a couple of things that we have going on that we could look at. I see a lot of options here. Let's go ahead and call this X. And I see that I can use this length here and these lengths here. This would be 7 plus x for that piece. I'm not going to look at the UV. That actually doesn't really help me. It's more of a distraction, so scribble that out. So what I would set up, this is the outside and the whole. So again, if I'm doing outside times the whole equals outside times the whole, that's going to give me 9 times 9 equals 7 times 7 plus x. Well, let's see what we would get. This is 81 equals 49 plus 7x. If we subtract 49 from each side, that would give us, that's like 82 minus 50, so 32 equals 7x. So we're looking at about 4.5 or so. That would be A. I don't even have to use a calculator because I know that 4 times 7 is 28, 5 times 7 is 35, so it's got to be between 4 and 5, which would mean A. B is out and C is out because those are over 5, too big, and D is definitely out. That's way too big. And that's what they asked us for, ST, right? Yeah, ST, that piece right there that I labeled X. Okay, I kind of scribbled through number 4. We are going to actually kind of skip number 4 for right now. And let's see what we can have. Are there other ones additional to this? We're going to skip number 5. But we are going to do number 6. It says find the radius of the circle to the nearest tenth. Okay, CD equals 18. CD is 18. And see how this is perpendicular here? that means that these two pieces are equal. So if the whole thing is 18, that means each half is 9. Okay. Okay, so let's see what's going on. Let's call this piece x. And what I see here is the Pythagorean theorem, because I have x for this leg, 9 to this leg, and this piece here is actually x plus 4. It's a radius, which is the same thing as that whole thing. Now let's color code that with the red line. Right there, that red line is x plus 4. So that's our hypotenuse. So we're going to have hypotenuse squared equals leg squared plus leg squared. Well, the hypotenuse is x plus 4. One of the legs is x, and the other one is 9. Well, x plus 4 squared, oh, I got to do some box multiplying here. X plus 4, that's x plus 4. So we got x squared, 4x, 4x, and then 16. We add all those things together, we'll get x squared plus 8x plus 16 equals x squared plus 81. Okay, well we can subtract x squared from each side. That was easy. Subtract 16 from the 81. We'll wind up having 8x equals, well, what's 81 minus 16? That's the same thing as 85 minus 20, or 65. So we're going to divide both sides by 8. It should be about 8. Is that right? Find the radius of the circle. Oh, here's what's crazy. So it's just over 8. So x is about 8. But that's not the whole radius, because the radius here is 8 plus 4, about, which would be 12. So the answer would be F. Alright, so that's the end of this piece. I know this one's dense. It's going to take practice, and we're going to practice it a lot, believe me, in the YouTube videos as well. So I'll see you in the review for mastery, but take 10 minutes just to attempt it. We'll go over it as well, but take a shot at it. See what you guys can do.